Hi, hello again. This is one more video for the Schumi UAV project for the model S22, which will be a 2.2 meter wingspan UAV platform. And I came here to one of our flying spots near Tavira, but because I wanted to fly a small EPO airplane, airplane today. It is a bit windy for that, so because the airplane is too small, too light for these wind conditions. So I'll take this moment to speak just a little bit more about the Schumi project, the Schumi UAV. And this time I will be speaking about the telemetry linkage between airplane and ground station. And I will have two options that can work simultaneously or independently or one at a time. The main telemetry, the main linkage between airplane and ground station will be LTE, 3G, 4G, 5G, and I will have an optional linkage system based on the 900 megahertz long-range telemetry radios, and I want to have those two options available because we might not have LTE coverage all the time. For example, in the desert, in a mountain, on the sea. There might be some moments that LTE connection is not available. It's not an option. So we have to count with the secondary telemetry system to assure the missions with this UAV platform. So for the LTE system, I'll be using as an interface between the autopilot and the ground station. I'll be using a Raspberry Pi board, just like this one. This one is the 3B Plus. It's the latest board that they have done. Okay, so basically we connect here in one of these USB ports a 4G dongle, an internet dongle that will be connected to a GSM provider, and on these GPIO pins I will be connecting the telemetry port of the autopilot. Okay, just let me grab here the LTE pen just to demonstrate. Okay, so it will be something here on the shadow, something like this. Of course, I'm gonna use an extension, an USB extension to have this dongle wherever I need it to be. Here we can connect external antennas for a better communication, better gains, and installed on this Raspberry Pi board, I'm gonna have, which is I have already. I've been testing it with a lot of success. A piece of software which is called, if I'm not wrong, UAVMatrix Pro from UAVcast. It's an awesome piece of software. It's really stable. There is just a few configurations to do before it gets ready to operate, but after that it just plug and wait about a minute and the communication is established. So the communication protocol that is being used, it's a TCP, which is much more reliable, and it works really well. You can use as a ground station simultaneously a computer and an iPad or a smartphone or a tablet, as long as it is connected to the internet. So that's it for one of the technical aspects of this project. I will need more boards like this one. Not necessarily the Pi B3 Plus, but it can be the Pi 3B, for example. So if you want to donate, you will be very welcome to donate some of these boards. And for the video, because the UAVMatrix Pro can send and receive telemetry in real time, almost no delay, or virtually no delay, and it can also send from the airplane to the ground station HD video stream with almost no latency either. This is, as I told you, this is a very complete system, piece of software, very efficient, very cheap. It's around $39 if I'm not wrong, but it works, just simple as that, and it's perfect. I'm in love with that system because it works like a charm. I'll be putting on the video description the link for UAVMatrix, and no, they are not sponsoring me. Well, guys, that's all for now. I hope you have enjoyed this video about how the telemetry will work on this platform. So if you want to sponsor me, you already know I prefer donations in a form of hardware rather than in a form of money. Okay, so you already know a piece of hardware that I gonna need will be Raspberry Pi 3B boards, whatever, if it is a simple B or a B plus, it doesn't matter. And very soon my Patreon page will be available. As soon as it is available, I will update the video description with a link where you can contribute for this project. Okay, so thank you.